Hi, everybody. Welcome to EDA Summit. My name is Albert Mavashev. I'm a CTO at meshIQ. And today I'm going to discuss Open Telemetry for the EDA MESH. And before we get into the discussion of Open Telemetry, I'd like to do a quick overview of what a mesh is and how diverse the mesh ecosystem is today. So in fact, if you look at the current integration or mesh space, you'll find a fairly diverse set of technologies, things like messaging, event processing, streaming, and there's also hybrid, especially things that are connecting to the cloud. So about, I would say, 15, 20 years ago, messaging has been fairly the most common way of how people would integrate applications together. Things like IBM MQ was conceived in the 90s and connected a lot of the financial applications together. But since then, there's been a proliferation of different integration technologies. And today, you have a fairly diverse ecosystem of different technologies for different kinds of use cases. Today, most of the organizations would use things like, IBM MQ, but there's lots of GMS. Today, Kafka is fairly popular. And then you've got fairly specialized and high performance messaging and integration platforms for event streaming like Solace, Tibco, and others. And then obviously a lot of applications today use also Kafka, especially for short messages and for aggregating lots of different time series data. Kafka is used for lots of different use cases. And then you've got a hybrid type of integration technologies that interconnect and actually live in the cloud, but interconnect on-prem as well as cloud type environments. And you'd find a fairly rich ecosystem on AWS, Azure, and other cloud platforms. So, and what happened over the years, especially in large organizations, all of these technologies kind of got connected to what I would call a mesh, meaning it's not just one technology connected, but it's really a heterogeneous set of things that are connected together. So different application groups pick different technologies, and at some point they've interconnected them in some way. So today you'll find IBM MQ footprints connected with Solace and connected with Kafka, and you have different pockets of technologies and applications, composite apps that are connected in different ways. And obviously with the introduction of cloud, you've got APIs and other cloud type of integration technologies that interconnect on-prem with business services as well as cloud. And obviously the main, or one of the challenges is, well, the infrastructure is so complex. How do you manage that, and obviously how do you monitor it? And the most common, or I would say traditional approach was, well, each vendor provided its own set of performance and all kinds of monitoring technologies and monitoring instrumentation, that whether that's APIs or collectors that allow you to monitor this infrastructure. So in a sense, Solace would have its own API, and so does MQ, and so does Kafka and Rabbit and Active. So all of them have their own, I would say, vendor-specific telemetry. And yes, you can connect to them and you can pull all these metrics in. Now the problem is if you just use one technology, it's not a problem. You use one API, but in the world we live in, you have multiple of these interconnected, and the ecosystem is fairly complex. And then you've got cloud. So how do you monitor this environment where each of these APIs or each of these vendors have their own vendor-specific APIs? And how do you understand from a semantic point, kind of like what is it? How do you monitor this environment, and how do you make sense of this? And in the mesh, especially, there's another set of problems. You have constant traffic moving across these pipes through your infrastructure. And the obvious problem comes out as a problem of tracing. How do you know where your messages are, and what's the latency of these messages, especially in the producer-consumer high throughput environments? Latency becomes an important factor. And typically, in a traditional approach, again, you get the vendor-specific APIs, you take all these metrics from different API vendors, whether it's Kafka, AWS, Solace, or MQ. You pipe those metrics into the data lake of some sort. Pick your favorite monitoring vendor. And then you apply different algos, and then you provide monitoring and analytics. So all seems great, except for that it's let's take a very specific use case. Let's take a tracing use case. It becomes a real problem. So let's just take a case where there's messages or millions of messages being exchanged between different applications via this integration mesh. And well, let's just say you got a problem where a message didn't arrive at the destination. And what do you do in that case? Well, typically in a traditional approach, so you've got all of these traces that you've collected from different endpoints, whether it's Kafka, Solace, or AWS. So technically speaking, you're going to have to do a search. So you're going to go, and whether it's in the data lake, you're going to search in the data lake for some common ID. So let's say it's a payment. So you're going to search for a payment and say, well, where is that payment? So it's a very painful process. It requires you searching through multiple logs, multiple data lakes, multiple applications, and trying to figure out what's going on. And even if you found those entries, how do you analyze, what that is? They may have different timestamps, different formats, different information that's being collected. So it's a fairly painful process of figuring out what's happening. And if you're part of a DevOps group or ops that's trying to figure this out, you're in a world of pain. So now, obviously with Open Telemetry it introduces a different approach and simplifies things in a serious way, and that is it introduces kind of a vendor agnostic way to collect telemetry metrics as well as traces. So you look at things that typically people look at is logs, traces, metrics, what I would also call transactions as well. Some traces, you think of it as a collection of messages that are related together in some sort of a fashion. So you have a vendor agnostic API. So there's really only one way to connect to and collect all of this information. And then you have a bunch of exporters that allow you to export Open Telemetry data into a specific data lake. Again, that's your monitoring vendor that you decide. And then there's a concept, obviously, of context and context propagation, and that allows you to connect things like applications and the integration mesh, the things that are in between the middleware, the messaging, and databases and other things that are in the cloud that's actually sits in between applications and your business services. So in a sense, it's a much cleaner approach because the vendors can plug in their own modules, whether it's Solace or Kafka or IBM, and provide Open Telemetry integrations. And in a sense, your monitoring gets simplified because there's only, there's really vendor agnostic way to connect and collect all of this telemetry. So that's obviously a significant step forward in managing this integration mesh. However, so if we look at this, a better approach in a sense, so before we had this kind of searches, so let's analyze kind of how the situation changes with introduction of Open Telemetry. So Open Telemetry, you've got instrumentation, let's say at each of these individual hops or endpoints. You collecting what they call spans. It's basically logical units of work of related activities or related events in a sense. And they're being kind of connected together in a hierarchical way, parent-child relationship, where you can say, well, the transaction started here and then split and then morphed across as it moves through the infrastructure. So it's a fairly, nice model of how do you connect these dots together. So there's really one way you put your Open Telemetry across your infrastructure, and then you collect your transactions. Again, you pipe that in, and it's a much better way to look at information. Instead of searching it, you kind of have a nice way of relating and correlating spans, or think of it as activities, logical groupings of activities across your application or composite app. Now, in theory, it obviously is a good idea, and you obviously want to do this, especially if you have a complex environment. But the obvious question really comes down to is, well, each of these spans is actually being collected at each of these endpoints, and then and they obviously could be run on different VMs. They're running in a completely they're not running on the same physical or virtual servers, and they could be also spread across different cloud environments. So how do you connect those spans together? How does one relate span A to span B to span C to span D and things like that? So there is a concept of a context propagation, and Open Telemetry introduces this concept that allows you to do this. Now, if we look at context propagation, it's logically, it does make sense, obviously, to connect these things together, but it also introduces a significant challenge. And the challenge is that you've got a situation where you need to inject context into in a sense, messages as these messages move across the integration mesh. So, for example, if an application A sent to an application B or C, it needs to inject the context into that message. So obviously the injection has to be paired with extraction, and that is, if you included context, it needs to be extracted at the application, and then obviously that context needs to pass across through the whole leg of the execution. And that is obviously, it is a solution, but it also is a significant challenge, because not only you need to include this injection points and extraction points, but you also need to have instrumentation that accomplishes that at each individual hop. So in a sense that, if it's an HTTP request, you obviously have to inject something into the HTTP header, and you have to extract it from an HTTP header. Now, when you deal with a complex, heterogeneous mesh, integration mesh, things get very complicated, because different protocols, different technologies, different header structures, different message structures. So, for example, a Kafka is a completely different structure than, for example, MQ. And the headers are structured differently, and everything is pretty much different. So how do you propagate that context across? Well, obviously, it's all implementation specific. So in a sense, you need those instrumentation points. They have to be also uniform, and they have to be present at each of these locations. So, for example, if you adopt a specific form of this instrumentation, it has to work across all of this environments. Now, that's easier said than done. In most cases, some of the integration providers would provide their own Open Telemetry and their own context implementations, but that doesn't necessarily mean it'll sync up with, let's say, IBM MQ or some other downstream. So that's a significant challenge in the integration. And again, it's because you have different implementations, different integration technologies, different protocols. If we had, let's say, one protocol, it would be obviously much easier. We adopt one way to do this. We inject and extract at each individual point. Now, there's another subtle point there is, if you typically inject things into the message, and again, it depends on the integration technology, then if extraction doesn't happen, it also is possible that it can break the application. Again, it all depends on how the injection is done. So, for example, if injection is done into the payload of the actual message, then that payload is, in a sense, is modified. If the application downstream is not aware of that modification, or it's not being extracted properly, then the application can potentially break down. So you have to be very careful with how context is being propagated, where the context is injected, how it's injected, and how it's extracted. And you want to make sure that your instrumentation, again, in this ecosystem, is deployed across all the hops and it's consistent and uniform. So that's an important note about context propagation, and I would say it's a fairly significant challenge, especially when we deal with heterogeneous integration meshes. Now, when we take so let's say we solve the problem with propagation. So now the idea is obviously take all of these traces and metrics that are being emitted by the Open Telemetry. You typically would pair it with an exporter that is allows you to take all of this telemetry and feed it into some kind of a data lake. Now, we at meshIQ, we provide a way to do that, including the instrumentation Open Telemetry exporter that allows us to take the metrics out, pipe into the data lake, and apply all kinds of analytic searches and apply statistics and things like that that allow you then to visualize your Open Telemetry ecosystem. And obviously, in a sense, in case of this, you want to be able to pipe in metrics, and you want to be able to collect traces, and I will also use the term transactions and messages out of this ecosystem. So that's a fairly common way that how you would analyze your integration. Now, in a sense, and the idea is like, what's the actual outcome of this? Well, the outcome is fairly straightforward. If we look at this integration ecosystem here, now, obviously, things that are being emitted is fairly cryptic. It's all data that's being piped into a data lake. You don't want to do searches and things like that. What you want is a nicely kind of visualized diagram of the flow. So in a sense, you've got applications that are connecting to other applications, and basically the routes or the arrows indicate the direction into where the information is flowing, and obviously statistics around it. And all of it is possible because you're able to observe traces coming out from different applications, parts of an application, and then you're able to connect those things together because of the context propagation. So that's usually, you would go from something that's fairly cryptic, where you're doing searches and manual pattern matching, to a correlated view and visualized view of the flow across the whole mesh. So that's really where you want to be at versus doing something like that. I want to thank you for attending this session. If you have any questions, this is my email. You can reach out to me and ask me about Open Telemetry or the mesh or any other topics that I discussed during this presentation. Thank you.